Actually, in relation to this challenge, this ITU, which is our International Telecommunication Union, it has also proposed some visions for 5G, or as we say for RMT 2020. We know this is a statutory name. And the description of the vision for this 5G is actually the picture on our left. It's this triangle, right? You've seen a lot of it, haven't you? We define the future 5G business as divided into 3 scenarios or 3 types. The first scenario, we call it eMBB. It's our enhanced mobile broadband. Of course, why do we call it enhanced? This is relative to our previous 4G or 3G. Actually, for our business, especially for our mobile-oriented business, we usually call it MBB. Actually, we mentioned this MBB when we were in 4G. We call it mobile broadband. Actually, we had this concept when we were in 4G. It provides broadband access to our individual users or home users through mobile means. Of course, compared to this MBB, we will have an FBB, right? Fixed broadband. This is a fixed method, right? For example, we access through fiber or Ethernet cable. So for this access, we divided it into 2 ways. One is this wired access method. One is this wireless access method. In the era of 4G, we can provide access capabilities similar to wired broadband through wireless means. Of course, it's just similar, right? We know that current wired broadband can provide wired optical broadband. We can provide a speed of 1 Gbps. It might even be higher. But for 4G, we might also call it broadband. But the speed is not so high. So in the era of 5G, we define this high-speed demand or high-speed application scenarios. We used an enhanced MBB, eMBB. So its focus is on high-speed scenarios. For example, our downlink speed requirement needs to reach 10 Gbps, even higher, 20 Gbps. So this is the first application scenario we defined, eMBB. It actually fits our high-speed challenge, high-speed demand. Another scenario is actually our URLLC. We call it ultra reliable and ultra low latency business. It provides a key indicator of 1 millisecond end-to-end delay. This 1 millisecond end-to-end delay actually reflects a control force, especially for our industrial control force. For this, we can easily associate. It is mainly applied in some of our this vehicle networking or this kind of intelligent manufacturing field, because it can provide better control for the industry through ultra low latency and ultra high reliability. Another point is our mMTC. We call it massive Internet of Things business in front of it. We also added a lowercase m. Of course, this is relative to the ordinary MTC, right? We know MTC is machine type communication, but in the era of 5G, we will add an M in front of it. It's massive because it needs to support a massive number of connections. Because for this machine type communication, we actually, in the era of 4G based on cellular machine type communication, we already have some technologies to support it, right? Like our well-known NB-IoT or our eMTC. Actually, they are all oriented towards machine type communication, some communication technology standards. It's just that during the NB-IoT and eMTC technology standards, the number of connections it can support or its connection capability is relatively limited. But in the era of 5G, what we need is a larger scale connection capability. So we call it mMTC scenario. Actually, it mainly reflects the M of large scale. So this third application scenario is our mMTC scenario, large scale machine type communication. So this is our definition of the future 5G business divided into these 3 scenarios or 3 types. What it will use is our Internet of Everything smart city. Well, a key indicator it proposes is to achieve 1 million connections per square kilometer. So this indicator will be much higher than our existing 4G based NB-IoT and eMTC capabilities. So it reflects this large scale. But actually this mMTC application scenario reflects a kind of connectivity. Whether it's object oriented or human oriented, it proposes a stronger connectivity. So this is our ITU's description of the 5G vision. It divides our business or industry into these 3 scenarios. Our future new businesses will all fit into these 3 scenarios. Of course, we will also have some new businesses. It may be 2 scenarios or even a combination of 3 scenarios. In fact, to cope with or match these 3 typical business scenarios, we will also have some very typical businesses or applications. For example, to match this eMBB enhanced mobile broadband service, what we can easily think of is this virtual reality, right? For this virtual reality business, it requires a higher speed because only through a higher speed can you get a better business experience. For example, your resolution will be higher. The color of your colors will be more brilliant. So we will combine the eMBB scenario. A very typical application we can think of is VR. Of course, we may also have some others such as AR or MR, including the combination of artificial intelligence will launch some new businesses. Of course, these businesses may all require higher speeds. Another one combined with this URLLC scenario. We just introduced it briefly, right? It mainly enables some key industries, right? Especially this vehicle networking, smart manufacturing and telemedicine. Because these are in this traditional industry, we don't need to go online, but in the future combined with this 5G and this URLLC scenario, these traditional vertical industries, after it goes online, it will bring a series of chemical reactions. It will make our society safer or to make our society better. The last point is our mMTC large scale machine things. In fact, we can already feel it in our current life, but it's not that large scale yet. We know that many of our home appliances now, or many of these, some cameras in the city have already been connected to the network. In the future, the number of things connected to the network will be larger. For example, there is a data here. It was Huawei's forecast data at the time. There will be 100 billion connections worldwide in 2025, but among these 100 billion connections, 90 billion are object connections. So we will see that in the future, more things are networked. So based on object connections, we will create such a smart home. This smart city will come faster. It will also make our life safer. This is ITU's description of the 5G vision. We defined 3 application scenarios. Combined with these 3 application scenarios, we will derive some typical businesses and applications. Of course, some businesses and applications may be relatively distant, like this vehicle networking. Maybe in the next 2 or 3 years, it may not enter our lives so quickly, but there are also some business applications like this. VR business application, it has gradually entered our lives now. You will see some VR games or some live videos, etc. This is ITU's description of the 5G vision. We defined these 3 scenarios. In fact, combined with these 3 scenarios, we just mentioned the first eMBB. It's actually our most typical application. It will be this VR, AR and MR. In fact, these 3 businesses actually require higher speeds to fit our eMBB application scenario. Actually, these 3 businesses, you've heard a lot about them, right? This VR, we know it's a virtual reality. For example, we will have some representative companies like Rift or Touch. They will provide such VR services and terminals, but we know the characteristics of this VR business. Everything you see is fake, right? It's all virtual. You're just immersed in a virtual environment. We emphasize an immersive experience, but we will have some enhanced business experiences. For example, this kind of AR, we call it augmented reality. This AR is about overlaying some virtual things on the real environment, but you can still distinguish which ones are real and which ones are fake. So this is the business of this kind of AR. Of course, this AR business, we will have some interactivity. That is, we have both real and virtual. You can do some interaction. This is the characteristic of AR business. Finally, we will also have a MR business, this kind of mixed reality. Of course, the definition of mixed reality business may not be very clear. Different companies may have some relatively differentiated statements, but the intended meaning is relatively clear. That is, we can interact with real and virtual objects. And in the MR environment, you may not be able to distinguish what is virtual and what is real. So its experience will be better. So it's immersive. Its interactive experience will be more realistic. Of course, there will also be some representative companies, right? Here is Microsoft's HoloLens. HoloLens company has already released some of these businesses and products. Of course, it has for civilian use and also for military use. So in the future, for example, based on this MR business, we can do some training and simulation for soldiers, some in battlefield conditions. So this kind of VR or AR or MR, in fact, it will not only be for civilian use, it may also be in some special industry fields. There will be some new applications. But whether it's AR, VR or MR, in fact, they all have higher requirements for speed. You want to see more exquisite patterns, more exquisite videos, clearer videos. In fact, all these require speed support. They all need data support. How do I transmit these data, possibly through wired methods? If we need to do it wirelessly, it puts higher and higher demands on speed. You want to see a clearer picture, you have to provide a higher speed. In fact, for these three businesses, VR, AR and MR, in terms of technical maturity, VR is the most mature. It will also be the first to enter our field of vision, but VR actually also has a development and evolution process. Our early cardboard VR, of course, this may have become a thing of the past, including the console VR we see more now, and the cloud VR that will soon enter our lives. They all appeared at different stages of VR development. In fact, for early cardboard VR, we just need a mobile phone, download the corresponding VR source. We put this phone in the cardboard glasses. We can experience a relatively rough, this kind of VR business experience, get a relatively rough VR business experience. But it also has some obvious disadvantages, right? For example, the effect is relatively poor, the clarity is relatively poor, and there may be some dizziness, but its characteristic is the cost of the terminal is very low. We can even buy a very rudimentary cardboard VR glasses for 9.9 yuan, right? Of course, if you want to get a better experience, the cost will definitely be relatively higher, right? It may be several hundred or even several thousand yuan in addition. For early cardboard devices, its control over content copyright is very limited because the content we get is all downloaded from the internet to local, so you can share the downloaded source, share it with your friends, share it with your colleagues. So the control over copyrighted content is very limited. This is the characteristic of the early stage, of course. This business model has already exited the mainstream market. Now we may see more of this. Console VR, in fact, it's just a fat mid-end plus. The VR content we get, why do we call it a fat mid-end? Because this mid-end is achieved through a high-performance console paired with a relatively high-performance VR glasses. Of course, the characteristic of this is our VR glasses. It needs to be connected by a cable to our high-performance PC high-performance console on a high-performance host. So this becomes a wired connection method. Then you would feel that it's not so convenient to move around, of course. This helmet is also relatively heavy. For this kind of scenario, the price of the whole high-end system is relatively expensive. For example, a high-performance PC might cost close to 10,000 yuan. So the whole high-end system, the total cost may exceed 10,000 yuan. So this will limit its promotion and popularization because everyone is quite sensitive to the price. But because its content is localized, we also get such content from the internet or from stores. But after we get this content, it is offline and localized. I can share it with my friends and colleagues. Similarly, it is difficult to control offline content. So it's quite challenging. So the copyright is relatively unprotected. There might also be some piracy issues. So this is our current host VR. Actually, this kind of host VR, everyone can now experience it in shopping malls. The cost of a single test experience may be tens of yuan or even close to 100 yuan if the experience is good. So the cost for a single user is still a bit high. Similarly, its content is not particularly rich. For example, when you go to the mall to experience it, you will find that the games you can play are always the same few. The content update is relatively slow. This is our current mainstream host VR, but in the future we will have this cloud VR, that is this kind of cloud VR. Its main purpose is to solve the shortcomings of mobile VR and PC VR. The feature of this cloud VR is that we need a thin client. We no longer need a thick client. What we need is this thin client. It only needs to receive the rendered data and present it. The entire image, processing and rendering is done in the cloud. In this way, we don't need a high-performance host. Then through the computing power of the cloud, it reduces the requirements for our client side. And our headset can also be wireless. How do we achieve wireless? Actually, this is where 5G comes into play. Then in this way, especially when we experience games, the perception will be better. You are free from the constraints of cables. For this traditional wired constraint, your movement range may only be within a 3x 3-meter range. But for this wireless scenario, our movement range will be wider, especially when we play some action games, the experience will be better. Similarly, through the cloud. Through this cloud VR, for this thin client, we can control the price within 2000 yuan, but it might be lower in the future, right? Another point is that we can control the content source in the cloud. In this way, copyright management will be more effective, because you need to pay to get an account. Through this account, you can experience this content, and this content will not be downloaded to the local. It will only download the real-time data stream. The overall content source is still in the cloud, so copyright management will be more efficient and it will be more secure in this way. This copyright issue is solved. It will also encourage content providers to be more active and proactive. In this way, we reduce the cost of the client side. Then this can bring the business to more people and promote the prosperity of the entire ecosystem, promote the closure of the entire business. This is the evolution of VR. We see, because we said for the eMBB scenario, VR might be the first wave of applications. And it is also a relatively clear business model at present. Of course, we said its ultimate development direction is this cloud VR. Of course, we said cloud VR. It can achieve this wireless connection. How does it achieve it? We have a lot of rendered data in the cloud to send down. This is when 5G comes into play, right? Our early cardboard VR or glasses VR, including our current relatively more PC VR, all have various restrictions, but the future cloud VR, it can solve these problems well. Our large amount of data rendered in the cloud sent to our VR glasses side through the high speed of 5G. In this way, we can get a better experience at the same time. Our mobility is also guaranteed. Of course, we also said the copyright management of this cloud VR is also very efficient. Of course, for cloud VR, it can achieve this wireless connection. In fact, it will have higher requirements for our mobile network. We mention a beginner level experience here. It requires a bandwidth of 100 megabits per second and a delay of 10 milliseconds. The bandwidth determines the quality and clarity of the VR video you see. The delay will determine whether you feel dizzy. If we watch VR videos, if the delay is large, you will feel noticeably dizzy. But if we keep the delay very low, the effect will be very good. For beginners, 100 megabits per second and 10 milliseconds of delay. Actually, the beginner level experience can basically be met by the current 4G network. But there may still be some pressure in terms of delay. Of course, if we want a single user to achieve a continuous 100 Mbps, it may be a bit difficult in the 4G network. Actually, everyone threw some of these apps to do some speed tests in a 4G environment. You may find that only the peak speed may reach 80 Mbps, 90 Mbps or 100 Mbps, but many times your speed may only be tens of Mbps, such as 20 Mbps, 30 Mbps, 40 Mbps. This average speed, it may be difficult to continuously achieve this beginner level VR experience. There will be some difficulties, but for 5G, there is no problem. The speed that 5G can support will be higher. It can support 10G or even speeds above 10G BPS. In this case, we can get a more extreme VR experience. For this extreme VR experience, we need a speed of 9.4 Gbps. This 2 millisecond super delay, but these are things that 4G cannot satisfy at all. This is also the advantage of 5G. Of course, the difference between our extreme experience and beginner level experience. Where is the difference? For example, our extreme experience, our entire screen may be 4K or even 8K, and our colors will be, for example, 2564 or even higher. At the same time, our frame rate will be higher. The overall effect and experience will be better. To satisfy this good VR experience, only the 5G network can satisfy. This is the value of our cloud VR. Of course, we said here only the 5G network can satisfy cloud VR. This extreme experience, of course, it doesn't mean we absolutely have to use 5G network. There are also some VR companies now provide some other solutions like Intel and Broadcom. They jointly proposed a wireless communication solution called wireless gigabit. It uses a technology similar to Wi-Fi It can also provide a speed of over 1 Gbps. Of course, we know that this Wi-Fi solution, its mobility will be worse because at the beginning of this system design, it did not consider the requirements of mobility management. At the same time, we know that the speed of Wi-Fi will be lower compared to 5G. So this is also the value of our 5G, the higher speed, and it can support mobility, and its overall delay control will be more efficient. Well, this is our cloud VR. This is the first scenario we see. For the eMBB scenario, cloud VR will become, or say our VR business will become the first wave of applications because it is also relatively mature.